When we have two sets of data which are correlated and we want to find the equation of the line of best fit, we can actually work it out by a relatively simple formula. Let's look at this data. We've highlighted x and y. We want to plot the scatter diagram. So we go to scatter, insert scatter, and there's the basic scatter diagram showing a good positive correlation. We want to find the best straight line through that data, and let's suppose that's going to be y equals a plus bx. So a will be the intercept and b will be the gradient. To find b, we use the following formula. In fact, we'll put b there and then we're ready to put it in there. To do this, we need to move the graph because I've got to do some work on these columns of data. We need to work out x times y for each pair of data and x squared. So to do this, let's do this cell. X times y will be equal, because it's a formula, the x value times the y value, and that gives us 4. And we can click and drag this from the bottom right of each cell, and that gives us all the products of x times y. We also need to add up work out all the x squareds. So formula x squared will give us 1 squared, which is 1. The others will be a bit more interesting. We get all the various squared numbers for x. We then have to add up these columns. So I'll click and drag down and put the totals in row 7, and we do a total by going to home and sigma. Same for y, home, sigma. xy, home and sigma, x squared, home and sigma. So now we can work out b, the gradient, and it's given by the following formula. It equals, it's a quotient of two expressions, one divided by the other. The top one is the sum of all the xy's divided by how many there are. There's 5, so it's the average value of xy minus the average value of x, so that's sigma x divided by 5 times the average value of y, which is the total of all the y's, divided by 5. That's the top of our expression. We then have to divide by a similar expression underneath, which in fact is just the variance of x, so it's the average of all the x squareds, so that's the total of x squared divided by 5 minus the average of x, which is the total x, divided by 5, and we have to square that. And then we put the whole thing underneath, and out pops the formula for the gradient in that line. That gives us b. We then find a, and the formula for a is the average value of y, so it's the total divided by 5, take away the b number times the average value of x, which is the total x divided by 5, and that gives us that. So our equation is y equals 3.5135 plus 0.864 etc. times x. That's the equation of the line of best fit, or the regression line of y on x.
Okay, Marie, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.